Hello and welcome. For this video, we're going to look over how we can make sure that we understand different ways that questions can be asked that require the same approaches. So, for example, here, part A and part B of the question ask the same thing, but they use different terminology. We need to be aware of the verbiage for each, and we need to be aware of how to determine the solution. Okay. So for part A, they say, hey, here's a function. It happens to be quadratic. It has one repeated root. Determine the values of k. Part B asks the same thing, but in a different way. For what values of k is the curve y equals x squared minus 2 times k minus 3x plus k tangent to the x-axis, right? And that's hard to say, so we usually just say the function. So for what value of k is that curve going to be tangent to the x-axis? Or for what value of k are we going to have one repeated root? Saying the same thing. Both saying that, hey, if I've got this parabola, what's going to be the value of k that sets up so that I intersect the x-axis once and only once? That means I need a perfect square for this quadratic. But it doesn't mean that the k value will be a perfect square. So what's an approach for solving this? Well, if I'm going to have one repeated root, if I'm going to be tangent to the x-axis, that discriminant, b squared minus 4ac, is going to need to be equal to 0. In this situation, what is the value of a? Well, the value of a is 1. What is the value of b? The value of b is the coefficient of x. That's negative 2 times k minus 3. And the constant is c, and in this case, the constant is k. So that means that I need to solve the following. I need to solve b squared, so that would mean 4 times k minus 3 squared minus 4 times 1 times k. I need to solve that being equal to 0. Okay, and if I'm going to solve that being equal to 0, I know that I can come over and say, hey, this is going to be some sort of quadratic, and it's going to have possibly two real roots, or it's going to possibly have only one repeated root, or it's going to have possibly no real roots, right? I don't know which of these I'm going to have, but I do know that I have a calculator. So I could come to my calculator and look to solve. Right, so let's say I come to my NumWorks calculator and I can come to my equation, and I've already typed in the equation that I have 4 times x minus 3 squared minus 4x being equal to 0. And I can come and solve the equation, and it gives me the two solutions. Here's what's kind of nice about the NumWorks calculator that works not all the time, but in certain situations, that if I were to come over here and say, hey, my variable isn't going to be an x, my variable is going to be a c, all right? Let's say I had my variable being c. It's still going to recognize this to be able to solve the equation. That's a very nice thing about the NumWorks calculator. But you have to be careful in how you use it, right? Because if I were to come to the grapher, I would be able to say, hey, come, let's look at my parabola. And I want to find out when that parabola is going to be equal to 0. And I could come and plot the graph of my parabola and be able to find, oh, okay, well, I'm going to be equal to 0 at this value, which happens to be 1.70. And over at this value, which happens to be 5.30, not giving the answer to three significant figures, but I can see those values, right? And if I come over then to write my answer, right, solving with GDC, with our graphic display calculator, we found that the value is going to be k needs to be equal to 7 plus or minus root 13 all over 2, right? And in fact, for this particular thing, if I wanted to look at my Desmos graphing calculator, I happen to have put this into Desmos, and I happen to have put the value of k to see if that is in fact tangent to the axis at one point. It does seem to be tangent at one point. And what if instead this k was minus, right? Right, if this k was minus, I could come over and I could see, hey, I'm tangent to the x-axis at one point there as well. But notice the value for k to 3 sig figs is going to be 1.70, 1.6972, right? And if I didn't have a k value, if rather I just had my slider for k, right, I could see that depending on the value for k, I might have more than one solution, right? Depending on that value for k, I might have more than one solution. I might have no solutions, or I might have only positive solutions, right? From this, it does not seem to have any value of k where I have positive solutions and negative solutions. So one of the nice things about the IB is it gets you to play around with those ideas, right? So k value is that. We said, though, if we were going to do it to 3 significant figures, it doesn't tell us, but we could say that k is approximately 1.69722, which means therefore k is approximately 1.70. Right, and if we came back and we looked at our other solution, right, we said that the other one was 5.3027. So we could say, hey, that k is approximately 5.3027, but once again, to 3 significant figures, that would be approximately 5.30. So solving a problem using a discriminant, but recognizing that neither of them says to use the discriminant. Thank you for your time.